and welcome back to my channel. Today we are looking at the question, why do we have weather extremes? So do subscribe down below if these are helpful for you. We'll be going through all of the topics that you need for your exams, so subscribe down below and let's get going. Tropical storms. Tropical storms have winds that exceed 118 kilometers an hour. They form at 5 to 15 degrees north and south of the equator in summer and autumn. They form where ocean temperatures are above 26.5 degrees centigrade, where two Hadley cells meet, causing hot, humid, unstable air to rise, condense and form storm clouds, where the Coriolis effect of the Earth's rotation is strong, which starts the storm to spin. Tropical storms are also known as cyclones, hurricanes or typhoons in different parts of the world. We're talking about the same thing here. They are extremely hazardous and they usually are measured using the Saffir-Simpson scale. Tropical winds are responsible for the mainly east to west tropical storm path. Tropical storm hazards could be coastal flooding caused by storm surges, landslides, which is where large quantities of rock or soil slide down saturated hillsides, strong winds destroying trees, power lines and buildings, storm surges, abnormally high sea levels because the air pressure is so low, and intense rainfall, up to 1,000 millimeters in a single storm from thick, dense clouds. So how do tropical storms form? Rising air draws high quantities of evaporated water vapour up from the ocean surfaces. This then cools and condenses into towering thunderstorm clouds. As the water vapour condenses, it releases heat, which powers up the storm and the ability to draw up more water vapour. Multiple thunderstorms join to form a giant rotating storm. The Coriolis effect spins over the storm at 118 kilometers an hour, creating a vast cloud spiral. Prevailing winds, so these are the winds, like the general direction of the winds, move the storm over the ocean surface like a spinning top. The storm gathers more energy as it picks up more and more energy from the evaporated water. On reaching land, the energy supply, the evaporated water which was supplying this storm, is cut off and therefore the storm weakens. So what's the structure and features of a tropical storm? The eye is at the centre. This is a column of rapidly sinking, cool air where conditions are fairly calm and there are no clouds. So this is in the centre of a storm. If you were to look at a map, you would be able to see the circular centre of the storm. There is nothing going on here. Then the outer edge of the eye, known as the eye wall, is where the fastest, most severe conditions, where strong winds, including tornadoes, and torrential rainfall happens. So you've got your eye and you've got your strongest winds around the side of the eye and the eye wall. The cumulonimbus clouds swirling around the eye bring in more rain. It's this lifting up of water vapour to fuel the storm. Tropical storms are associated with extremely strong winds, often gusting more than 300 kilometers an hour, but they move over the ocean slowly. So they're spinning really quickly, but their actual physical movement on a map, quite slow. So what about droughts? Droughts are long periods where there is less precipitation, so rain, hail, sleet or snow, than usual, leading to water shortages. They are linked to long periods of high pressure. They are increasing in frequency due to the long-term climate change impacts, and they are also less violent than tropical storms, but their impact on humans can be deadly. El Nino and La Nina. Okay, so El Nino and La Nina are events that are caused by changes in the sea surface temperature in a band across the Pacific Ocean. So El Nino, we'll talk about this first. What are the causes of El Nino? The weaker trade winds increase the sea surface temperature in the tropical eastern Pacific, causing the El Nino effect every 3 to 5 years. So the trade winds are weaker, so they're not cooling down the surface temperature as much, and so the El Nino effect begins to occur. So what are the consequences? There are changes to the world's precipitation patterns as a result of El Nino. There are more tropical storms in the Pacific, there are fewer tropical storms in the Atlantic, and there are more droughts in Asia. And then La Nina. What are the causes of La Nina? Strong trade winds. So this is El Nino is weak trade winds, La Nina is strong trade winds. These decrease the surface temperature in the tropical eastern Pacific, causing the La Nina effect every 3 to 5 years. What are the consequences? Again, changes to the world's precipitation patterns. They cause weaker storms, weaker tropical storms in the Pacific, and stronger tropical storms in the Atlantic. So we're near the Atlantic, the Pacific for us is on the other side of the world, and this also brings droughts in South America. So El Nino is droughts in Asia as a result of like weaker or like more tropical storms there, and so all that like air mass has moved over to the Pacific rather than staying in Asia. Whereas La Nina, the droughts are in South America, as the strongest storms are now in the Pacific. So it takes that water vapor away that's needed for a tropical storm into the Pacific, and therefore there is drought in South America. So I do hope this has been useful. Do subscribe down below. If you would like any of my revision guides, they are all in the description for you. Go and pick them up. If you would like to get your Access All Areas for this exam board, yeah, that is also down in the description. You will get all the access to the revision guides, lessons, live tutoring sessions if you would like them, Q&A with me, exam questions, retrieval questions, they're all there for you. You can also submit essays and exam questions and I will mark them for you. So I do hope this has been useful. Do subscribe down below if it has been, and I will see you next time. Bye guys.